Welcome. This is our in-class activity for July 12th, and we're on to our part 2 of our lateral thinking discussion. So today, what I want you to do is download the document for the second lateral thinking chunk, and in this one, we're going to go over some exercises together, and then what you'll turn in today is the team name, student names, your selfie, and then we'll walk through how to apply what we're going to learn today to the problem of rush hour. I'll give a couple examples of that. So on the document that you downloaded, the second technique in the lateral thinking bag of tricks is called destroying all assumptions and questioning everything. And so a lot of times when we are trying to think through new ideas, we'll poke on some of the assumptions that we have, because a lot of the assumptions we have, again, they're assumptions, which usually means we don't even realize that we are treating something as truth that we actually don't know whether it's really true or not. And so we can poke on those a little bit and get some of those assumptions that are a little bit closer to the surface. What we don't often do, though, is drive that technique completely into the ground and question every aspect of every part of the problem. And so I want to give you some examples of how you can do that and what a difference it can make in terms of really coming up with creative solutions. And in a sense, you could almost look at this technique as, at least in part, identifying loopholes, looking at what the rules of the game are, and then destroying all the assumptions about all the additional rules that you make based off of that original set. Our mind usually adds some, based on what we're imagining, we create additional rules and restrictions on ourselves that aren't reflected in the rules, or the, if we're looking at a problem, we think of all these things on, oh, well, we can't do that because that's just the way things are. And so destroying all assumptions tears all that apart, and then really you start to build up, hey, which of these assumptions really are true, and which of them are fuzzier than we thought, and we really can find a new way around it. So that's what we're going to look at today. So I've come up with a number of different exercises. So what I'd like you to do with those, and I'd like you to be honest as a group and follow along with me, because I think it'll be more fun that way, is with each one of these, I'll give you the problem and then pause the video, spend 1 to 2 minutes on coming up with as many solutions as possible, and then unpause the video and I can walk you through some of the answers. So let's look at this first one. So this problem says, make these 3 matches into 6, no breaking into pieces. So I want you to think about that and see what you can do with that, and see how many different solutions you can come up with. There's one primary solution in terms of the people who've made this problem, what they consider the solution to be. However, if you truly destroy all assumptions, there's a lot of different solutions to this that fully fit within the rules. So pause the video, come up with some ideas, and then unpause the video. Okay, so hopefully you have some ideas now. Now what I want to guide you through is, this is, in a sense, this is the entirety of our rule book right here. This describes the problem we need to solve and the rules around it. So what I want to do is start really destroying all the assumptions I have, because even if you don't realize it, every one of us, when we just read this, we put additional restrictions on ourselves that we didn't realize we had, and I'll show it to you. So let's start with the word make. So it says make these 3 matches into 6. So let's question what they mean by make. Do you mean convert? Do you mean start from scratch? How do we make something? How do we make 3 into 6? So that's a little uncertain. We'll come back to that. It says these. Are we talking about these here or something else? Well, we'll come back to that because it seems like we're talking about these, and we probably are, but I don't want to set these things as certain. We want to potentially come back to these. So make these three matches. So it's three, the number three. So we're assuming that three means 1, 2, and 3. Um, and when it says matches, we're talking about matchsticks is the assumption we're making. Maybe it is, maybe it isn't. Now, when it says matches, if there was another way to interpret the word matches, so maybe things that match each other, you could go into that. Now, if you think about it for a while, it's probably talking about matchsticks because it's hard to think about what's really matching here. They are identical, but at the same time, I'm not sure what to do with it. But we're going to keep that fuzzy and not say that we validated that assumption. Now, when it also says matches, even if we do say it's a matchstick, well, there aren't any real matchsticks here. Right now, I'm looking at a computer screen with some pixels that are in the shape of something my brain is telling me is identified as what might be a matchstick. So that's a far cry from a real matchstick. So when we're looking at this, we say, oh yeah, we're going to make these three things into six. We're going to duplicate them. But at the end of the day, when it says matches, assuming we're talking about matchsticks here, these aren't matchsticks at all. These are pixels of red, blue, and green in a variety of ways that are represented here, and on a Word document that in itself is just a bunch of zeros and ones. And you guys are watching this from a YouTube video, so it's even further removed from anything that can be regarded as reality. So because of that, and knowing that the people who made this question weren't going to actually give you matchsticks, they gave you this picture, we have to realize that the assumption of what it means to have a matchstick is fuzzy at best. Right now we're talking about pixels. We're talking about little bits of light. So nothing physical here. So we might make use of that. So make these three matches into six. And what's interesting is it doesn't say make these three matchsticks into six matchsticks. It doesn't say copy these and double them. It doesn't say any of that. It just says make these three matches into six. And what we assign as kind of a silent letter or word in this case is we think make these three matches into six matches, because we see a picture here and we can almost imagine three more matchsticks that are here. And so the question is, how do we turn that into all six? But really, it didn't say that. It said these three matches into six. So six what? Six matchsticks, the number six, anything that's in six pieces. So that's another assumption we're destroying. And then no breaking into pieces. So I could look at breaking. What does it mean to break? What happens if I slice them down the middle? They can, if you look at what a matchstick is, what it does, if I slice it down the middle, each half can still operate as a match. Now, if I slice it this way, then I have a matchstick and then a regular stick. But does breaking mean separating at all? Which is kind of what we initially assume. But what if I sliced it or did any number of things to turn it into more than one of itself? It says into pieces. So what do we mean by pieces? So a lot of different interesting things. So maybe we can break it into a different shape if we're trying to make the number of six. Because if we break it, but we don't completely break it off, then it's not into pieces. So this really gives us a whole lot of different things to play with. So what seemed like an impossible task, because we can't clone these things and make three new physical matchsticks out of the original three. But once we've destroyed all the assumptions, we actually have a whole lot of different solutions. So in this case, they softball it to you to where they really don't need you to do very much. And the textbook answer is to take this match and leave it here, and then slightly shift these into a V, and it's actually these two into a V, and then this one into leave it there. And then you have the Roman numeral 6, so a V, which is 5, and then an I, which is 1. So that's the textbook answer. However, there's so many other things that you can do with this. So first off, if I break it but not into pieces, I can just take these and I can break this one at a 90-degree angle and this one at a 90-degree angle, and then I can make the number 6. I can also slice them and make those 3 turn into 3 more because I sliced them in half, and I can do that. Now, breaking it even further and destroying those other assumptions, if I consider what they call matches to be points of light, then there's nothing to prevent me from simply copying this image and pasting it. So I just instantly made 3 into 6 because I know that they're not talking about physical matchsticks because I'm not looking at physical matchsticks. I could also, if this was a printout, I could make a copy of it. I could just draw 3 more because it doesn't have to say, it never says they have to be identical in any way. If I happen to have 3 matchsticks, I just add them on there because it didn't say no creating, adding new material. It just says the only rule is no breaking into pieces. I could even pull a mirror out and hold a mirror against it, and then I would have 6. Or I could take a picture with my phone and hold my phone up next to it, and I would have 6. So there's a whole number of different ways you can do this. So if you're limiting yourself to how do we adjust these physical things, then you really haven't destroyed all the assumptions. You destroyed one assumption, which is thinking 6 equals 6 matches and not the number 6. So we want to take it further to really get into lateral thinking. We have to destroy everything in terms of assumptions. So here's another one, and this one's probably pretty easy for you to do the textbook answer. So connect all 9 dots with exactly 4 lines without lifting your pen. So I want you to pause the video, spend a minute or so, draw out what you think is the answer, and then unpause. Okay, so hopefully you have what looks like a line and a triangle, and the assumption that you had to break to get to that is we look at these dots and we've even if you quickly figured it out, I would guess that every one of us, when we see these dots, don't just see these dots, we see a box, and we've assigned borders to this box, even though there aren't any borders by any means. But we look at this and we automatically, our brain says, recognize that pattern, it's a square, and a square has these sides. When really, it's 9 dots. It has nothing to do with the square. But the way it's arranged, our brain goes ahead and auto-corrects that for us and puts those lines there. And by doing that, there's part of our brain that says, okay, how do we connect them using 4 lines? So if you assume that a line is straight, which let's go ahead and do, that means I can move here, I can move here, I can move diagonal, kind of tic-tac-toe wins, and that's it. And so you have to break the assumption of I have to stay within this box, which isn't even a real box. So you have to go beyond that in order to make your triangle to get all the pieces together. So with that, we have the textbook solution, but let's take it further. So it says connect all 9 dots. How do we connect the dots? And then it kind of tells us, it says with exactly, so exactly is pretty firm, 4 lines. Now, what is a line? Is it, starting at one place, ending at another? Let's assume it is for now, but recognize it's an assumption, it might be wrong. Let's also assume it has to be straight without lifting your pen. So some of my assumptions say, so we're going to have to draw 4 lines, we're going to have to not lift our pen, we're going to have to connect the 9 dots. Now again, and also assuming these 9 dots are what they're talking about. And from that standpoint, I think we can, because this is the only input they give us. There's 9 objects here, so I would assume that those are the dots. Connecting them with lines would indicate we have to draw a line through the dots, and as long as the line touches some part of the dot and goes from one to the other, then they're connected. And it says without lifting your pen, so if you really wanted to, it says connect all 9 dots with exactly 4 lines. It doesn't say what the lines have to be made out of. It just says without lifting your pen. So if you wanted to really loophole this and frustrate the person asking you the question, which I would highly encourage you to do so, if I wanted to be, and part of lateral thinking, especially destroying all assumptions, sometimes there is going to be some conflict because the person who asked you the question made assumptions when they wrote the question and assumed that you would make the same assumptions that they did and would look at the problem exactly the same as they had assumed and implied. And what you're saying is, if you really wanted me to follow that rule, you would have written down that rule. And so a key example of that is, okay, connect all 9 dots. I'm going to agree with you that these are the 9 dots with exactly 4 lines. Okay, I can draw 4 lines without lifting your pen. So if I take this and separate it, the without lifting your pen, if I separate that from the 4 lines, then what I would do is I would have a pen and I would lay it down on the paper, and then I would go get a pencil or a paintbrush or something else, and then I would draw 1, 2, 3 lines, and then another one just for kicks because I have to have exactly 4 lines. Now I only needed 3 to connect everything. I'm going to put the other one over here just for fun. But they don't have to be connected because it doesn't say those lines all have to be connected. It says the dots have to be connected. So maybe 1, 2, 3, and there's a horizontal line that connects those lines, and that way all the 9 dots are truly connected. So maybe that's a better way to do it. But I never lifted my pen, which destroys the assumption that you have to draw the lines without any change in continuity. Essentially, you have to draw one continuous line with 4 different changes of direction in it, is what your brain is telling you. That's what that says, but it really isn't. So another thing I could do, I could, again, these are bits of light and they're not really physical dots, so I could copy them and move them around to where they were all in one single line, and then draw one line, and then, you know, if I'm using my pen, then draw some others. I could argue even that I can't use my pen at all, depending on when the question was asked, because if my pen is lying down and you ask me that question, if I use the pen to draw anything, I've lifted my pen in order to do that. We're assuming that without lifting your pen means without taking your pen off of the paper. Also, it implies that we can draw exactly 4 lines and nothing else. So I could draw a line and draw, you know, whatever I want and get it at a different angle and then connect it this way. Because as long as the lines are connected and they are connecting the dots, then I haven't broken the rules, because it just says connect the dots with exactly 4 lines. It doesn't say anything else about anything else I want to do. But I would argue I've violated the question already if I lifted my pen in order to start drawing lines. So I would use a different writing implement just for fun, just to prove the point. But you can move these dots around, because it never says don't move the dots around. If I did have a piece of paper with this, I could fold them over and then essentially stab through with a writing utensil to make a first line and then make some other lines just for fun. Or I could fold them over and then just cross all the lines together over that. I could also draw a line with a very, very slight angle, knowing that it's going to barely increase so little that by the time, or maybe decrease, so that by the time that line goes all the way around the world, it's going to be right here by the time it goes around, and then all the way around again and right there. And then I could draw 3 extra lines to get exactly 4 lines. So I could do it any number of ways. Okay, so this one I want you to look at, and this is, we don't have anything visual here to look at, so this one might be a little harder. So a man parks his car outside the hotel and realizes that he's bankrupt. So explain. So with that, pause and talk about that for a minute and then come back. Okay, so hopefully you have some ideas or maybe a complete lack of idea. But let's break down the assumptions. So a man, do we mean a human adult male that is a real person? Do we mean an animated person, a metaphor, a general term for a human being, a general term for a human-like shape of something? Parks his car. So what does it mean to park? Or is he in the car and he drives it and then he stops driving? Or does park mean he just stops this thing that we're calling a car, which could be a real car, could be a toy car, could be a metaphoric car, outside the hotel. Now, one thing before I go further, I want you all to realize that when you read this, you actually created a whole scene in your head about what you read. So I'm sure a number of you pictured this man. I'm sure you pictured what he was wearing. I'm sure you pictured what his car looked like. I'm sure you pictured what the hotel looked like and where he parked the car. So I myself am thinking like a New York street, and if the hotel's kind of a high rise, I'm thinking he's in. I can even tell you, I pictured him in a gray suit with a red convertible. I have no idea why I picture that, but even after doing this a number of times, that's what comes into my head. Even though I know the answer and it has nothing to do with any of that, my brain will still put those words together and paint a whole picture for me that I don't even realize exists unless I destroy all the assumptions and I realize that as I'm picking away at that the visual that I've created is one of many interpretations. So I want you to picture what your brain visualized as we destroyed these assumptions. So outside the hotel, what is a hotel? We're talking a real hotel. Again, is that a metaphor? Is it a play hotel? Is it part of a game? And realizes that he's bankrupt. Well, are we talking about he realizes that he doesn't have any money anymore? Is he morally bankrupt? Is that a metaphor for something else? And so I break apart all these assumptions, and then I realize that there's actually a fairly small chance that it's a regular, adult human living male in reality parking an actual car outside an actual hotel and then realizing he's bankrupt. That doesn't make a lot of sense. But if I break all of those down and realize that I don't know what a man is, I don't know what a car is, I don't know what a hotel is, and I don't know what the word bankrupt means in this case. So I start to, if I say it might not be reality, since that doesn't make sense, where else might I see these different words and concepts together? So I pull out the word man, car, hotel, and bankrupt, and then I look at those words as this fuzziness of not physical, real items, but any type of representation. And then it dawns on me that bankrupt is probably the key, because I don't hear that very often. I hear bankrupt and I hear hotel, and I think, well, when might you go bankrupt? When you interact with a hotel. And then I think, wasn't there a game I used to play where a hotel, had this negative feeling because you could go bankrupt? And I think well, yeah, Monopoly. And bankrupt, if it's somebody else's hotel, you might lose all your money. And I think, well, what does a man in his car have to do with that? And then I remember that the car is one of the objects, one of the play pieces that you can have. And then the man might be, an actual man playing the game, and his piece is the car, and he lands on someone else's spot who has a hotel, and then realizes that because of that move, he's lost all his money. And so we solve the puzzle, but we have to destroy it all. And in this case, because there's so many different interpretations, we pull another trick by pulling some of those keywords out and then seeing where have I seen all those words together before. Okay, let's keep going. So the candle problem, similar to one of these, where you're given a candle, box of thumbtacks, and a box of matches, and you're asked to fix the lit candle to the wall so it will not drip onto the table below. So if I break that down, and we can do the same thing, the textbook answer is you use function fixation and realize that the box holding the thumbtacks is actually one of your assets. And you can thumbtack the box to the wall, light the candle, put it on the box as a sconce, and there you go. But that's boring and really doesn't destroy all the assumptions. So if I look at this, the one thing that you are assuming is that we would like to use the candle as a lighting source for the table. And so that's the assumption that you just made without it saying those words at all. We jump to that conclusion. But if I look at this, that might have been the person's intent. But if somebody told me this and said, you need to come up with a solution, and I had them sign a waiver saying, okay, I'm going to come up with a solution that will solve this, but I can't be blamed for what's about to happen, then I'm going to have some fun with it. So I could do any number of things. My requirements are assuming all of this is real stuff. So that's another assumption that I'm choosing to make just for the sake of expediency. So we need to fix the lit candle to the wall. So it doesn't say what we need to fix it with. So I'm going to light the candle because it needs to be lit. And what if the easiest thing would be to light the candle, fix it to the wall by pushing it against it. So you could call that surface tension is what we're using to fix it. And put it under the table. So on the ground, against the wall, light the candle, you're done. Now, if the person said all of this because they wanted you to create a sconce, well, it's their fault for not saying we want you to create a sconce out of this or figure out some way to light the table area. So we've fully realized what they've said and followed all their instructions, came up with a very simple solution without really any sort of heartache. In fact, we only used two of the items of everything that was available. And this is the type of lateral thinking that generates elegantly simple solutions that no one has been able to come up with, because everyone has created additional rules that don't actually exist. So they've created the rule that it's a lighting source for the table. Now they've also created a bunch of other rules. So for instance, I could do that, make the sconce, and then just to be safe that wax isn't going to drip, I could move the table out of that room. For that matter, I could take the candle and all it has to do is fix the lit candle to the wall. So if this is what we're calling the wall, then I could go into the other room that shares this wall and put it on that side. For that matter, if I wanted to be really snarky, I could cut out a hole in the wall, place that piece of drywall on the ground, and just set the candle on top of that, which would be kind of funny. Now, again, I could also affix it to the wall or set it on the ground next to the wall, and then I could light the table on fire, so the table burns up and therefore guarantees that wax will not drip onto the table because the table no longer exists. So I could even do that. Again, that's why you haven't signed the waiver. But all of those would solve the problem that they are asking me to solve. And again, so sometimes conflict, after you've burned someone's table and they wanted you to just make a fun light for them, the argument that ensues is, no, that what I meant was And so that's where you need to be careful not to seem kind of pompous and smart alecky. But the real point is to for that person, but also for yourself, when you're generating requirements, that you do a good job of destroying your own assumptions about what you're asking for and making sure that those true requirements and the real problem you're trying to solve is clear. It's also why um, by saying what the problem really is, the key problem, is important because I could take this and I could ruin the real problem you're trying to solve and follow all the instructions perfectly fine. So if I were to say, the problem I'm trying to solve is I want to have um, this table area, I want it to provide more light or soft light because I want to have a nice fancy dinner. Then that would eliminate the candle being under the table or burning the table up or ripping holes in the wall. Then I'm probably going to make a sconce because I know what problem you're trying to solve. So that has a number of lessons in it from both sides. So what I want you to do with the time left is I want you to take some of the assumptions of rush hour. So what assumptions can you find with the concept of rush hour? So especially coming back to are the roads just too small to fit all the cars? Well, can you drive on the road just fine at 2 in the morning? If so, then the roads probably aren't the issue. Um, so why are we assuming that rush hour needs to exist? And then backing into that, if you say, well, because people have to go in the morning and the evening, well, why do they have to? What causes them to all magically do that? Well, their jobs start and stop. Well, why do their jobs start and stop? What causes that to happen? And so we can get more into that when we're all together again. But I want you to take that road down and get to those assumptions. All right, and then fill that in, and then we will come back next time and we'll hit the last chunk of lateral thinking.